So let this is a resistor of resistance R. The conductance of this particular resistor is 1 by R. So this resistor is the source of thermal noise or white noise. So this resistor can be replaced by a conductance of conductance G in parallel with a current source. We are replacing a noise, or we are replacing a resistor which is the source of noise by a noiseless conductance. This is noiseless conductance in parallel with a current source. Here it is the noise current source with the power spectral density 2 kT into a resistance which can be considered as source of the thermal noise is replaced by a noiseless conductance with conductance G, where this G is equivalent to 1 by R in parallel with a current source, noise current source. This is IN of T. The subscript N indicates it's a noise current source with power spectral density 2 kT into G. So this is called the modeling of a noise source. Resistor itself is the source of noise, source of thermal noise. So we are modeling that as, or we are replacing that particular resistor by a noiseless conductance in parallel with a noise current source. Or otherwise, we can also replace this with a noiseless resistor in series with a noise voltage source Vn of T. So this or the last network is the Thevenin equivalent of the second network or the middle one. So here this Vn of T is equivalent to In of T into R. What is the power spectral density here? Vn of omega whole square is equivalent to In of omega whole square into R square. What this Vn of omega whole square indicates? This is the power spectral density of the voltage. This mod Vn of omega whole square is the power spectral density of the Vn, which is equivalent to the power spectral density of the In of T. So I write it as Si of omega into R square. What is Si of omega? It is the power spectral density of the noise current. Sv of omega is the power spectral density of the noise voltage. So this is the relationship between the power spectral density of the noise voltage, power spectral density of the noise current, and the resistance. So from this, so therefore substitute that here, this is 2 kT G into R square, which is equivalent to 2 kT into R. So therefore here the power spectral density is equivalent to 2 kT into R. So therefore from this we can conclude that a resistor which is the source of thermal noise can be replaced by a noiseless conductance in parallel with a noise current source with power spectral density 2 kTg. Or the resistor can be replaced by a noiseless resistor in series with a noise voltage source with power spectral density 2 kT into R. This is R. So this is the modeling of a noise source. So this is the Thevenin equivalent. You can consider this as the figure B. So this last figure indicates the Thevenin equivalent. So this and this both are equivalent. This network is equivalent to this. But this representation is applicable only to a single resistor. But if you have more than one resistor, if you consider a circuit, the circuit may consist of more than one resistor. So in such case, so this representation is not valid when the number of resistors are more than one. For one resistor, for a single resistor, this is the correct modeling. If you have more than one resistor, we need to generalize this concept. For that we have the GNT,